Oh, good morning, everybody. 5/14, May 14th. We're less than a month. We can do it. We've got to finish strong. I'm so proud of most of you. Most of you are doing a great job. Everybody's grades are going up because you're getting lots of help. If you just try, you should get at least a B in the class. Just try, okay? Now, if you're one of those few that's not doing anything, you might have to take either parts of the class over this summer, or you might have to take the whole class over next year. So start working, please. And if you have friends that you see aren't doing anything, kick their butts, get them going, okay? So first of all, let's take a look at yesterday's homework. So yesterday's homework is a little bit hard. You needed the distance formula to do it, so let's take a look at what we have, okay? So let's go to section 10.4. I'm getting there. Really, I'm getting there, honestly. All right, I'm getting there, really. Hold on. Okay, here we go. Okay, so what makes this difficult, okay, is your right triangles don't work very well, okay? You could, if you wanted to, I suppose you could feasibly make some right triangles like right here. You could use Pythagoras theorem, but I just used the distance formula, okay, because I thought the distance formula was easier. I've got 2 points. Distance formula is x2 minus x1 squared plus y2 minus y1 squared. So I went my -3 minus my -1 squared plus my 0 minus my -2, and then I ended up getting a -2 squared, which is 4, positive 2 squared, which is 4. 4 plus 4 is the square root of 8, which is about 2.8. Okay, so I did the same thing here. Here's my 2 points. And I've got my x2 minus my x1. I've got my y2 minus my y1. I'm just using this distance formula. I get 6 squared is 6, 36. 6 squared is 6. 36 plus 36 is 72. Square root of 72 is about 8.5. I did the same thing down here. I used my 2 points here and here. I've got my x2 minus my x1. Sorry, guys. And then same thing, y2 minus y1, and I use the distance formula again. If you want to get a right, you could probably do it by making a right triangle in here and using Pythagoras theorem. That'll also work. It's one method of doing it. Same thing here. I thought the distance formula would be easier to do it. Here's my 2 points. Nope, here's my 2 points. Sorry, my bad. Here's my x2 minus my x1, quantity squared, y2 minus y1, quantity squared. Okay, or I suppose if you needed to do Pythagoras theorem, you could find a little mini, like a right triangle right in there, okay? So, anyway, over here on 5, there's not enough information. We don't know if this is perpendicular or 90. There's none. 6, since these two are 90, 90, we know that P is parallel to Q. We don't know anything about R and S. Nope. 7, both sets are parallel because 90, 90. So J is parallel to K, and we know 90, 90, 90. So either N is parallel to M. They both are. Here, if angle 1 is equal to angle 2, then it's got to be 90, 90, which means both sets of lines are parallel 90, 90, 90, 90. Okay? Anyway, let's take a look at today's lesson. Okay? So today's lesson is kind of hard, but we're going to be smart. Okay? So, what are we going to do? Well, first of all, our objective today is to find the distance from a point to a line. Now this is a hard, I'll be honest, it's not hard for me, no, but this is a pretty hard lesson for most freshmen, okay? So we're going to do it in 2 days, okay? This is going to be a 2-day lesson. We'll do the first day today, and then tomorrow we'll do the second half of this lesson. So 10.5 is going to be done in 2 days, okay? We'll do the first page of the journal today, second page of the journal tomorrow. Okay, so what do we know about perpendicular lines? Perpendicular lines, we know they cross at 90 degrees, okay? Right? That's perpendicular, okay? 90 degrees. But what do we know more specifically is about their slopes. Remember, slope sets rise over run. But we know the slopes of perpendicular lines are opposite. what does that mean? What does opposite mean? Well, mathematically, m is the symbol for slope. Remember, m is rise over run. So let's say one slope happens to be some fraction a over b, okay? Could be maybe 2/3. Could be maybe, I don't know, 3 over 1. It's perpendicular slope. You ready? Look at this. It's a fraction, rise over run. It's the opposite. So it's going to be a b over a. Flip it and make it negative. Okay, so don't get totally opposite. Flip it, and then I make it negative. Okay, that's opposite slope. Okay, so let's look at example 1. Oh, first let me give you an example of this. Just a simple example. Okay, let's say I happen to have one slope that happens to be 2/3. Its perpendicular slope would be, flip it, right? Make it opposite. Okay, so this is up 2 over 3, up 2 over 3. This would be down 3. So up 2 over 3, up 2 over 3. I can give you a little example of that up here. You can see this, I know. So using my two examples, up 2 over 3. The other would be down 3 over 2. And you can see that they look perpendicular, don't they? Okay, anyway, moving on. Example 1. So here we go. This is what we want to do. Find the distance from point A to the line. Okay, so we want to find from here to this line right here. Okay, so what I want to do is draw in a line, but it's got to be perpendicular. Okay, because the shortest distance is the perpendicular line. The shortest distance is the perpendicular line. Okay, now what I need to use to do this whole thing is I need the distance formula. So write that up there. Distance formula. D is equal to, let's write this up. Big square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, that's my distance formula. Okay, I'll write it again over here so we have it. Sorry, so sloppy. Put it back over here. Okay, so let's go back to this. What I need, I need the distance from this point to this line. So what I want to do is make them perpendicular. First. Alright, so the slope of line, let's just call it line L. So my slope of my line is 3. Up 3 over 1. Up 3, 1, 2, 3 over 1. Up 3 over 1. Up 3 over 1. Okay, so the slope of this line is up 3 over 1. We need to find the perpendicular slope, okay? So I'm going to find this perpendicular slope, which would be the opposite of that. And so my opposite slope is going to be, instead of 3 over 1, it's going to be 1 over 3, but negative. Okay? Now, I want to draw in this line, but I want it to be perpendicular. I want to draw in this line, but I want it to be perpendicular. So I'm going to use this slope to make them perpendicular. So here's what we're going to do. We're going to go, instead of up 3 over 1, we're going to go from here down 1 over 1, 2, 3. Down 1 over 1, 2, 3. And I can draw in my line. So I also find out where the two lines intersect. Okay, so let's call this point B. So point B has the coordinate of 2, 6. Okay, now if I want to find the length of AB, because that's what I'm looking for, is the distance from this point to this line. And obviously the shortest distance is straight across to it at 90, okay? So to do that, I need the distance formula, okay? So here is my first point, x1, y1. Here's my second point, x2, y2. And I'm going to use my distance formula, okay? So I'm going to go, distance is equal to the big square root of, ready? Let's just use it. Big square root of parentheses. x2, which is 2, subtract x1, which is a negative 1. I get a double negative squared plus y2, which is 6, minus y1, which is a 7, squared. Okay, so far so good. Double negative. Okay, distance is equal to the square root of 3. 3 squared is 9, plus negative 1. Negative 1 squared is 1. I get the square root of 10, which is the distance, and on my calculator, I go the square root of 10 is about 3.16. So the distance from A to the line is about 3.16. Okay? All right. Number 2. Example 2 is very similar. We're going to keep practicing this, okay? Now, in example 2, this is formula because we're going to need it. We're going to go d is equal to the big square root x2 minus x1 squared plus y2 minus y1 squared. Okay, so point A is at negative 9, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3. Okay, there's point A. And we want to find this line, y equals x minus 6. So we'll go down to 1, 2, 3, 4, 5, 6, because that's the y-intercept. I know the slope of this line is up 1 over 1, up 1 over 1, up 1 over 1. I'm going to keep the line going this direction. Draw my line. Okay, this is my line. It's my line. Y equals x minus 6. Okay, so first of all, what is the slope? Okay, the slope of my line is 1 over 1. So its perpendicular slope is going to be, flip it, negative 1 over 1. But I made a negative too, okay? So from point A, I'm going to walk point A with this opposite slope because I want to cross it 90 degrees. So I'll start at point A and I'm going to walk it down 1 over 1, 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 okay? And what I do is I found out where the point intersects the line. Right there. Let's call that point B. Okay, I want the length of AB. So I want the length of AB. To find that, I'll need the distance from it. So point A is at negative 9, negative 3, and point B, let's see, point B is at, let's see, it's at negative 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's going to be at negative 3, negative 9. Huh, it's kind of weird. Opposite numbers. Yeah, it's just the way it is. Just pure coincidence. Just pure coincidence. Okay, so if we're going to use our distance formula, right, we're going to need x2, x1, y2, y1. So let's make that x1, y1 first point. We'll make this x2, y2 second point. So let's use our distance formula. I'm going to use this right here. D for the distance equal to the big square root of x2, parentheses x2, which is my negative 3, subtract x1, which is my negative 9, a double negative, quantity squared, plus parentheses y2, which is negative 9, subtract y1, which is a negative 3, quantity squared. Okay. All right, I got my double negatives. Boom, 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 boom. Okay. Distance equal to big square root. Let's see, that's negative 3 plus 9 is 6. 6 squared is 36. Plus negative 9 plus 3 is a negative 6, but negative 6 squared is a positive 36. 36 plus 36 is 72. Square root is 72. I just need my calculator. Square root of 72. And I get an answer of about 8.48. Approximately equals. So that's that length. It's about 8.48. Okay, got it. Okay, turn the page. And again, if I'm going too fast, just pause. Okay, so same kind of question, except for they just word it differently. Okay, So find the distance. So I'm going to put up the distance formula again. Distance is equal to the big square root. x2 minus x1 squared plus y2 minus y1 squared. So let's go ahead and graph this. Find the distance from the point -5, -3. 1, 2, 3, 4, 5. 1, 2, 3. Okay, there's point A. And then it's going to be a line has to pass through 2, -4. 1, 2, 3, 4 passes through, and has a slope of -3. Well, if it's got a slope of -3 over 1, let's just make the line, okay? So I'm going to go down 3, right? -3 over 1, down 3 over 1. Let's just do the opposite. 3, 1, 3, 1, because we need to draw the whole line, right? Draw my line. Okay, so here's my line. So probably right there is it. I'm not sure, but I'm going to go ahead and do my up 3 over 1, up 3 over 1. So I'm going to go, because I'm going to do my opposite slope, which is positive 1 over 3. So instead of down 3 over 1, we're going to go up 1 over 3. Up 1 over 3. Boom. There's my point of intersection. Let's call that point B. Okay, I like this. So the shortest distance is where it crosses at 90 degrees, which is perpendicular. Okay, shortest distance is where it crosses at 90 degrees. So we want the length of AB. Okay, so if I want the length of AB, I'm going to use my distance formula again. So point A is at -5, -3, and point B is at the point, let's see, 1, -1. So let's call this my first point, x1, y1, my second point, x2, y2. Oh, by the way, it does not matter which point you call point 1, point 2. Somebody might ask that. This could be point 2, this could be point 1. Does not matter, okay? The formula will work. So let's do our formula. Here's our distance formula. So let's go big square root. You ready? Using the formula. Parentheses, x2, which is -1, subtract x1, which is a -5 squared. Double negative. Parentheses, y2, which is -1. Or did I make a mistake? I did. It's a positive 1. Shoot. There you go. Glad I caught that. There we go. Back to this. Okay, you guys see my mistake? My mistake was that's a positive 1. Okay, now, caught that because that's my -1 minus my -3 squared. Okay, double negatives make that plus, 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 plus. See what I got? Big square root of, see that's a 6. 6 squared is 36. Plus, that's a 2. 2 squared is 4. The square root of 40, what is that? I don't know. It's a calculus made for, right? Square root of 40. And I get an answer of about 6.32. 6.32, sorry, dyslexic. Okay, so that's it. Now, homework. And I'm only going to give you 5 of these. So you're going to do page 299, 1 to 5 all. Okay, so if you take a look at it, page 299. Page 299, let's take a look at it. Okay, and we're only going to do 1 through 5 all. Now, I would suggest graphing all of these. Okay, I would suggest graph all. Okay, and then show your work. Okay, and then tomorrow we'll do the other half of this assignment. Okay, so that's all I have. I'll talk to you tomorrow.